Have you ever just stopped and wondered how an AI can take a really long, complicated paragraph and translate it without completely losing the plot halfway through? It seems like a simple task for a computer, but for a really long time, it was a massive, massive problem. So today, we're going to dig into the incredible breakthrough that taught machines a very human skill, how to focus.
So let's just start with that puzzle, right? If you feed an AI a long sentence, how on earth does it keep track of everything? How does it know that a word at the very beginning connects to a word way at the end? For a long time, this was a huge stumbling block for AI. And the way they first tried to solve it, well, it had a really serious flaw.
Okay, so to get to the solution, we've got to talk about what came before it. Let's meet the absolute workhorse of early AI translation, the encoder-decoder architecture. This thing was the go-to model, the standard framework for pretty much any task where you needed to turn one sequence of information into another.
In this model was a real jack of all trades. Seriously, the same basic idea wasn't just for translating French to English. Nope, it could look at a picture and write a caption for it. It could even watch a video clip and describe what was happening. It was the key to bridging the gap between all these different kinds of data.
So here's the gist of how it worked. The first part, the encoder, was kind of like a funnel. It would read an entire sentence, let's say in English, and it would have to cram all of that meaning, every single nuance, into one compressed summary. Basically just a list of numbers. Then the second part, the decoder, had to take only that one summary and build the entire translation from scratch. It had no way to go back and look at the original sentence again.
So, are you starting to see the problem here? Forcing all that information through one single point creates this massive bottleneck, especially when you have long sentences. This super powerful, super versatile architecture had this surprisingly simple, or as one of the researchers who worked on it called it, a silly flaw.
And that's not my word. That's the word they actually used in the paper. Silly. The model tries to digest and memorize the entire input all in one go. Can you imagine the pressure? It puts this immense burden on that one little summary to capture every single detail, every relationship between words. It's a huge ask. Think about how a person translates something. You don't read and memorize an entire paragraph at once, right? Of course not. You look back and forth. You focus on a specific phrase here, a word there, as you're writing. The machine, though, it was being forced to memorize everything up front. It's just a totally unnatural and pretty inefficient way to work.
So clearly, this wasn't going to cut it for long. The AI needed a better way. And the solution that researchers came up with was, well, it was beautifully intuitive. Instead of forcing the model to memorize everything, what if we could just teach it to pay attention, just like a person does?
And this idea led to the birth of the attention mechanism. The name says it all, really. Instead of relying on that one static, crammed, full summary, this new technique allows the model to look back at the original sentence as it's generating each new word and decide for itself what's most important to focus on in that exact moment. Okay, so here's a really simple breakdown of how it works. First, for every single new word it's about to write, the model glances back at the entire original sentence. Next, it gives every word in that original sentence an importance score. Think of it like a relevancy score. Then, it creates a brand new targeted summary that focuses only on the words that got the highest scores. And finally, it uses that focused summary to spit out the next word in the translation. And it just does this over and over again in a loop for every single word.
Now, this all sounds great in theory, right? But here comes the part that is just so cool. We don't just have to trust that the model is paying attention. We can actually watch it happen. Because remember those importance scores we just talked about? Well, by looking at those scores, we can create a heat map, a visual guide to the model's focus. We can literally see the alignment between the original words and the new words as they're being created. It's incredible. And here it is. This is the visual proof. So on the left, you've got the French words the model is writing, and across the top, you've got the original English words. And do you see that strong diagonal line forming? Look, when the model writes the French word zone, its attention, that X, peaks right over the English word area. When it writes économique, boom, its focus snaps right to economic. It figured out this perfect word-for-word alignment all by itself.
So what's the big deal here? What's the takeaway? This wasn't just some minor adjustment. The attention mechanism was a fundamental shift in how we build these AI models. It was just a smarter, more intuitive, and ultimately, a more human-like way for a machine to handle information.
The real genius of this whole approach is that it's just a better modeling choice. It's more aligned with how complex information is actually processed in the real world. But the most mind-blowing part of all this? Nobody ever told the model where to look.
No one programmed it to align zone with area. It learned this sophisticated human-like skill of focusing all on its own, just as a side effect of trying to get the translation right.
This breakthrough completely changed the game, and it became a core building block for pretty much all of modern AI, which, it leaves us with a really fascinating question to chew on. If we successfully taught machines how to pay attention, what's the next human skill we should teach them?